111 degrees. That is the forecast high for Billings, Montana today, Sunday, July 12th. That number would be the hottest temperature ever recorded in 92 years of records at that station. Not a record for the date, not a record for July, an all-time record, and Billings is not alone. Right now, as you watch this, the western United States is sitting under the most powerful blocking high-pressure ridge the National Weather Service has seen this season. The Weather Prediction Center issued its short-range forecast discussion just hours ago at 4 a.m. Eastern Time, and the language in that document is striking. Dangerous heat reaching its peak today from the Great Basin to the northern plains. All-time record highs possible. That phrase, all-time record highs possible, does not appear in routine forecast discussions. It appears when something genuinely unusual is happening. And here is what makes this situation different from anything we have tracked this summer. 2 weeks ago, the eastern half of this country was under a historic heat dome. Over 200 million Americans were at risk. New York City hit 100 degrees for the first time in 14 years. Atlantic City, New Jersey, reached 106 degrees on the 4th of July, an all-time city record. Washington, D.C., hit 103. Boston hit 101. That dome eventually broke down. People who live in the east thought the worst was behind them. They were wrong. What is happening right now is the second chapter of the same story. The heat did not leave North America. It relocated, it shifted west, reorganized under a new and arguably more powerful ridge, and it is now bearing down on a region that was already in severe to extreme drought going into this weekend. The western United States does not have the humidity that makes eastern heat feel suffocating. But it has something the east does not: extreme dryness, depleted soil moisture, and the lowest snowpack in recent memory. When you pair those conditions with 110-degree air, the consequences go well beyond human health. Here is who needs to watch this the most right now. If you are in Billings, Montana, if you are anywhere in the Wasatch Front in Utah, Salt Lake City, Provo, Ogden, you need to be taking this seriously today. If you are in Casper, Wyoming, or Grand Junction, Colorado, you're in the zone where the National Weather Service has placed extreme heat warnings through tonight. And if you're planning to visit any of the national parks in this corridor, Yellowstone, Grand Teton, Glacier, the Mighty Five in Utah, be aware that conditions in those parks this weekend are not what visitors typically expect in summer. Salt Lake City is forecast to reach 106 or 107 degrees today. The city's all-time high temperature record, set 5 separate times and most recently in September of 2022, is 107 degrees. The National Weather Service office in Salt Lake City, in its own forecast discussion released this week, called this the most significant heat wave thus far this season. That is a direct quote from official NWS forecasters. This is not model speculation. This is what the people who issue the warnings are saying about their own city. Let me put that in perspective. Salt Lake City began keeping temperature records in 1874, 152 years of records, and the city is today approaching the highest temperature it has ever recorded. That is the scale of what is happening right now across the Intermountain West, and if Salt Lake is approaching its all-time record, what about Billings? The latest AccuWeather and Weather Channel data put the Billings forecast high today at 111 degrees, 111. The city's all-time record is 108 degrees, set on July 14th, 2002. If Billings hits that forecast, it does not tie the record, it breaks it, by 3 degrees. In a city that has been keeping records since 1934, Casper, Wyoming, is watching a forecast high that could tie its own all-time record. Grand Junction, Colorado, at around 105 to 106 degrees, is within striking distance of its all-time mark of 107. The NWS WPC discussion this morning notes specifically that an intensifying upper-level high centered over the western United States is working in concert with an upper-level trough digging toward the Pacific Northwest. That combination, a massive ridge to the east, a trough to the west, is essentially squeezing hot air upward and trapping it over a wide swath of terrain. Where are you watching from right now? If you are anywhere from Nevada east of the Dakotas or anywhere in the Mountain West, I want to know what temperatures you are seeing outside. Drop your city and your current temperature in the comments. Now here is what people in the Midwest and East need to understand, because the heat is not staying in the West. This dome is moving. Let's get into the 7-day breakdown, because the eastward progression of this system is the part of the forecast that should have everyone paying attention from the Rockies all the way to the Atlantic coast. Today, Sunday, July 12th, is the peak day for the western core of this heat dome. The Intermountain West, Montana, Wyoming, Utah, and Nevada are experiencing the worst of it right now. Overnight lows tonight across these areas will struggle to drop below the low to mid-70s. That is a critical detail. Your body needs overnight relief to recover from daytime heat stress. When overnight lows stay in the 70s, there is no recovery window. That compounds the health risk significantly. By Monday, July 13th, the ridge begins to shift its core eastward. Sizzling conditions start creeping into the foothills of the Rockies and more of the Central Plains. Denver, which has been watching this system from the edge, is expected to see its high climb toward the upper 90s to near 100 degrees on Monday and Tuesday. Denver's all-time record is 105 degrees. The city is not going to break that Monday, but it will likely post one of the hottest temperatures it has seen so far this year. AccuWeather forecasters note that Monday and Tuesday are expected to be the hottest days of this stretch for the Denver area. Tuesday, July 14th is when the heat begins to affect the upper Midwest in a serious way. Minneapolis, which has topped out at 92 degrees so far this year, is expected to push into the middle to upper 90s and potentially reach 100 degrees or beyond. Minneapolis hitting 100 degrees would be significant. It does not happen often, and when you add humidity back into the picture, as the dome advances eastward and draws Gulf moisture northward, the apparent temperature climbs well above what the thermometer reads. AccuWeather has Minneapolis, Des Moines, St. Louis, Omaha, and Kansas City, all in a potential corridor of 95 to 105 degree highs by Tuesday into Wednesday. Let me stop here for a moment and tell you what the Climate Prediction Center said specifically. They used the phrase, hazardous heat expected, with highs in the 90s to low 100s, along with record-breaking highs Thursday through Saturday. They also said, and this is important, the combination of hot temperatures and high humidity will create heat indices up to 105 to 110 degrees. Overnight temperatures will provide little relief as lows drop to the mid to upper 70s to 80s. That language, overnight lows in the upper 70s to 80s in the Midwest, tells me this next wave of heat is going to be particularly dangerous, not just for people without air conditioning, but for infrastructure. Power grids across the northern plains and Midwest are going to face sustained demand they are not designed to handle simultaneously for multiple consecutive days. The potential for rolling outages grows when this type of heat persists for more than 48 hours. Wednesday, July 15th. Heat indices of 105 to 110 degrees, likely across Kansas City, Chicago, St. Louis, and the Ohio Valley. Chicago, which has seen a high of 95 degrees so far this summer, may see its hottest day of the year around this time frame. I want to be careful here. There is still some uncertainty about exactly how far the eastern edge of the dome extends, but the ensemble guidance from both the GFS and the European model are in strong agreement that the upper Midwest and Great Plains face a prolonged stretch. By the second half of next week, Thursday into the weekend of July 18th and 19th, the East Coast gets another shot of dangerous heat. The first heat dome in late June into early 4th of July brought New York, Philadelphia, Boston, and Washington to triple digits. This time, the model suggests the most extreme temperatures may stay centered over the Midwest, with the Mid-Atlantic seeing highs in the 90s to near 100 before a cold front finally provides relief. But I will be watching the European ensembles closely as this week develops, because they have been trending the dome slightly stronger and slightly further east with each new model run. Here is the broader question that I think about when I look at this pattern. We are 2 heat domes in, it is only mid-July, and the summer still has 10 weeks left. The last time I tracked back-to-back heat dome events of this magnitude across the continental United States, separated by just 1 week, with the first affecting the eastern 2/3 and the second developing in the west, was during the summer of 2012, and that summer became one of the most significant in the modern climate record. But here is where this summer gets complicated in a way that 2012 did not. And this is the part of the story I want to spend real time on, because it explains why this heat is not a random event. It explains why we are going to be dealing with these conditions repeatedly through the rest of this summer and into the fall. The driver is El Niño. And the El Niño that is developing in the Pacific right now is not a routine event. It is not a moderate El Niño. It may not even be a strong El Niño. The data released this week, and I mean data from the last 72 hours, is pointing at something we have only seen a handful of times in recorded history. NOAA's Climate Prediction Center updated its El Niño advisory earlier this week. The alert status reads as follows: El Niño continues and will strengthen through the end of the year. 97% chance it will persist through early spring 2027. NOAA is assigning a 63% probability to a very strong El Niño, meaning sea surface temperatures in the monitored region of the Pacific exceeding 2 degrees Celsius above average during the peak window of November 2026 through January 2027. Now here is what that number means in practice. Very strong El Niño events, those exceeding 2 degrees Celsius, have only occurred 5 times in the historical record going back to 1950. The last one was the 2015 to 2016 event. Before that, 1997 to 1998. These events do not happen every decade. They are exceptional, and NOAA, as of this week, is giving a 63% chance that this becomes one of them. But it gets deeper than that. The European Centre for Medium-Range Weather Forecasts, the ECMWF, in its early July update projected that Pacific water temperatures in the monitored region could top 3 degrees Celsius above average, possibly as early as September, peaking in autumn or early winter. If the ECMWF is correct, this would not be a very strong El Niño, it would be a super El Niño. NOAA's own Geophysical Fluid Dynamics Laboratory ran its model 30 times in its July forecast update. Every single run, all 30, projected a peak El Niño strength that was described as competitive with the strongest events observed over the past century. Every single one. Climate scientist Daniel Swain, who has been tracking this event closely, posted as recently as yesterday, July 10th, that the latest update showed another upward shift in predicted El Niño peak intensity in the multi-model ensemble median. He added that the single most likely outcome is now a very strong super El Niño event. I've been watching El Niño development data for years. I want to be precise here and not overstate what we know. El Niño forecasts issued in July for a peak in November still carry uncertainty. But the direction of every new model run, every single update this month, has been stronger than the one before it. That consistency is meaningful. When models keep revising in the same direction, that is a signal worth taking seriously. So what does a super El Niño mean for what you're experiencing right now? This is the connection that most of the coverage is missing. People are seeing individual heat events and treating them as separate stories. Atlantic City hits 106, then a week later, Billings may hit 111. These are not separate stories. They are the same story. The atmospheric reorganization driven by a rapidly warming equatorial Pacific that is already reshaping where the jet stream sits, where ridges build, and where heat gets trapped. Severe Weather Europe published a detailed analysis this week connecting the 2026 summer pattern directly to the emerging super El Niño. Their analysis of the mid-level velocity potential, essentially a map of where the atmosphere is rising and sinking, shows a signature that matches the fingerprint of the last 4 super El Niño events. The pattern produces a persistent omega block over the central United States. High pressure locks in over the interior. The jet stream gets pushed northward and remains there for extended periods, and the result at the surface is exactly what we are tracking right now. Repeated heat dome events across different regions of the country, developing in succession. I want to give you a number that I think captures the scale of this event. As of yesterday, wildfires had already burned more than 3.3 million acres across the United States this year. That is significantly above the historical average for this point in the calendar. Most of that burn has been concentrated in the west. Colorado and Utah have seen destructive fires in recent weeks. The Iron Fire in Utah alone burned more than 37,000 acres before containment efforts brought it under control. Now take that landscape, 3.3 million acres burned, historically low snowpack, soil moisture already depleted, and add 110-degree heat. The fire risk across the Intermountain West this weekend is not theoretical. The National Weather Service in Salt Lake City specifically flagged in its forecast discussion this week that gusty winds and low relative humidity would create critical fire weather conditions before the peak heat arrives. Daniel Swain, in his Weather West analysis posted just 17 hours ago, assessed a 20 to 30% chance of dry thunderstorms over Northern California mountains Sunday through Monday, with a good chance that some dry lightning and subsequent wildfire ignitions will occur. He was careful to note these may not be widespread, but he said they will materialize. Think about what dry thunderstorms mean in this context. Lightning without significant rainfall. The strike ignites dry vegetation that is already primed to burn after months of drought and record heat, and the tree or bush does not immediately show fire. Climate scientist Swain specifically noted this weekend that fires from dry lightning can take a day or two to show themselves, smouldering quietly before conditions warm up and dry out. His words, he would not at all be surprised to see fire weather risk areas expanded or upgraded from elevated to critical. There is a second fire concern beyond dry lightning, the North American monsoon. This is typically welcomed across the desert southwest because it brings moisture and breaks the heat in Arizona, New Mexico and parts of Colorado. AccuWeather's long-range team expects the monsoon to become active toward the middle of July. But the monsoon arrival in a drought-stressed landscape does not automatically mean relief. AccuWeather's Brandon Buckingham noted in a forecast discussion this week that initially, the monsoon may produce little rainfall with the storms, and the dry lightning and wildfire danger during those early dry storm phases can increase substantially. The lightning-induced wildfire risk does not disappear when moisture starts to arrive. For a period of several days, it may actually peak. Let me give you the next layer of this story, because it reaches beyond fire and heat. The extreme heat events of the past 2 weeks have already produced secondary hazards that most people did not anticipate. When the eastern heat dome was at its peak, thunderstorms erupted along its edges, a phenomenon AccuWeather had previously described as a ring of fire pattern. Roughly 250,000 customers in New Jersey lost power from storms on July 3rd alone. Ottawa, Canada, recorded 118 millimeters of rain in a single event, a stunning total, as the heat dome's edge interacted with a frontal system. That flooding wiped out Canada Day celebrations in the National Capital Region. The same dynamic will play out again this week as the dome shifts eastward. Storms develop along the dome's periphery where atmospheric instability meets the moist air mass being drawn northward. The Gulf Coast and central Texas are already in the picture. The Weather Prediction Center's excessive rainfall discussion from this morning specifically noted a slight risk of excessive rainfall across portions of Texas into the central Gulf Coast on Monday into Tuesday, July 14th. Precipitable water values across central and eastern Texas are expected to exceed 2 inches, some areas potentially topping 2¼ inches, with weak steering winds supporting training and back-building convection. That is a flash flooding setup. So the heat dome's eastern edge brings flooding potential to Texas and the Gulf Coast. At the same time, the western core is baking Montana and Utah. This is one system doing 2 things simultaneously, scorching the interior and drenching the margins. Now I want to address something that is important for the longer range, because if you're watching this and thinking, when does this end? The honest answer, based on what the models are currently showing, is that this summer's pattern is unlikely to simply normalize. Let me explain why. Arthur here. Welcome to Skyspace Lab. If you want to stay ahead of these developing weather systems through the rest of this summer and beyond, hit the subscribe button now. What we are tracking in real time requires daily attention. The data is changing fast. What the El Ninyo development means for late July and August is this. The Climate Prediction Center's summer seasonal outlook, and this is the official NOAA product, is projecting above normal temperatures for a vast portion of the United States through the end of July and into August. The probability of above normal temperatures is not evenly distributed. The highest probability regions include the western United States, the northern plains, and parts of the upper Midwest. These are the same regions that are being hit hardest right now. Above normal does not mean extreme heat every day, but it means the baseline is elevated. When a heat event hits, and they are going to keep hitting, it starts from a higher floor. Severe Weather Europe's analysis of historical Super El Niño summers shows a consistent signal. The pressure anomaly pattern across the United States during late summer and early fall in Super El Niño years shows a persistent high pressure anomaly over the central United States extending into southern Canada. What that means physically is that the Omega block pattern we are watching right now, with a ridge pinned over the interior and jet stream displaced far to the north, has historical precedent for lasting well beyond a single month. The 4 previous Super El Niño events all produce some version of this locked-in summer pattern. The heat is not random. It is the expected atmospheric response to what is happening in the Pacific. There is one more layer I want to bring in here, because it is relevant to the current fire and drought situation in a way that matters for the next several months. The NOAA Fire Outlook updated this week shows above normal wildfire potential persisting across virtually every western state through the end of July. Extreme to exceptional drought is most widespread across the eastern Great Basin, central Rockies, and central High Plains. That drought is expected to persist and expand across most of the northern half of the West through September. When you read that, drought expected to persist and expand through September, in the context of a super El Niño summer that is generating repeated heat dome events, you begin to understand that the fire season in the West is not in the middle of the story. It is still near the beginning. The broader drought picture deserves a separate moment. The eastern Great Basin, that is Nevada, western Utah, is in some of the worst drought conditions we have seen in years. Western Nebraska, western Kansas, and northeastern Colorado are also in severe to extreme drought. AccuWeather's drought analysis from this week specifically noted that the incoming heat dome is expected to merge and expand the drought from the Rockies to the plains, creating, in their words, one continuous zone of stress. One continuous zone from the Rockies to the plains, that is not a localized dry spell, that is a continental-scale soil moisture deficit that is going to affect agriculture, water resources, and fire behavior for months. Corn and soybean crops across the central Midwest are already under stress. AccuWeather analysts noted that this second heat dome is expected to bring little to no rainfall beneath its core, a critical distinction. Unlike severe thunderstorm setups where storms fire inside the heated air mass, heat dome interiors suppress convection. The sky clears, the sun bakes, and crops that needed rain this week will not get it. I want to tell you about a specific number from the NWS Billings forecast discussion that caught my attention this week. The center pressure of this incoming ridge, the upper level high parked over the west right now, may set records by 5 millibars in multiple states. 5 millibars. That is a significant departure even for an extreme ridge. What it means practically is that the atmospheric cap, the lid that suppresses cooling, is stronger than what these regions typically experience even during intense summer heat events. The higher the center pressure, the more efficiently the system traps heat at the surface. There is essentially no escape valve. Let me come back to the immediate situation in the West today, because there is something happening right now in the fire weather picture that I think is going to escalate in the next 24 to 48 hours. Along the western flank of this ridge, a surge of monsoonal moisture is being pushed northwestward into California and the Great Basin. On paper, moisture sounds like good news, but climate scientist Daniel Swain's analysis from early this morning, posted on Weather West just hours ago, assesses a 20% chance of mostly dry thunderstorms over southern California mountains today and tomorrow, and a 20 to 30% chance of mostly dry thunderstorms over northern California, including the San Francisco and Monterey Bay area Sunday through Monday. He stated clearly that dry lightning will probably materialize and will probably yield at least a few wildfire ignitions. Here is how that works mechanically. The monsoonal moisture surges northwestward at mid-levels. It generates thunderstorm activity in the mountains. But the lower levels of the atmosphere are so hot and so dry that rain evaporates before it reaches the ground. The technical term is virga, precipitation that falls from a cloud but never reaches the surface. The lightning still makes contact. The spark lands on vegetation that has been baking for weeks at record heat under record drought, and it ignites. This is not speculation. 2 wildfires in Utah that started this pattern earlier in the season, one of which was tracked at over 37,000 acres, followed exactly this sequence. And with the drought footprint now larger and the soil moisture more depleted, the threshold for ignition is lower, which means the risk for each individual lightning strike producing a significant fire is higher than it was at any point earlier in the season. This is one of the most dangerous compound wildfire setups I have tracked in a summer like this in recent memory, and I say that with the specific data in front of me. 3.3 million acres burned year to date, already well above the historical average, a drought footprint that the NOAA Fire Outlook expects to expand through September, and a heat dome producing all-time record challenges today in at least 3 cities, with dry lightning ignitions assessed as probable by a leading climate scientist this morning. There is a cold front eventually in this picture. That is worth noting. For the East Coast, AccuWeather's forecast team is signaling that after a day or two of extreme heat mid to late next week, a front pushes southward and provides relief to the Atlantic seaboard. But for the interior west and the northern plains and Midwest, the models are showing that the ridge strengthens again rather than collapsing outright. The dome does not disappear. It oscillates between the western interior and the central plains. Temperatures in the 95 to 105 degree range for Kansas City, Denver, Minneapolis, and Des Moines are not a one-week story. AccuWeather's extended forecast team noted that the heat dome will strengthen again over the plains rather than weaken later next week, bringing a potential extended period of 90 to 105 degree temperatures across the central United States. And this returns us to El Niño, because the reason the ridge keeps rebuilding, the reason there is no clean pattern change on the horizon, is that the atmospheric reorganization being driven by the warming Pacific has a persistence to it that does not resolve quickly. NOAA's Climate Prediction Center shows El Niño at 97% probability of continuing through early spring 2027. The World Meteorological Organization states that the most rapid strengthening of this event is expected during July through September, right now, over the next 10 weeks. The atmospheric forcing from the Pacific is not peaking, it is increasing. The last time I tracked an El Niño event strengthening this rapidly, with model runs consistently revising the peak intensity upward, was the lead up to the 1997 to 1998 event. That year, the peak Nino 3.4 index reached 2.3 degrees Celsius above average. This year, some model runs are projecting a peak that could rival or exceed that. If the ECMWF's early July projection of 3 degrees above average in the monitored region verifies, and that would make this one of the strongest events ever recorded, the atmospheric response across North America this autumn and winter would be unlike anything most people alive today have experienced. I am not forecasting that outcome. I want to be clear about the uncertainty here. Model projections issued in July for events peaking in November carry real error bars. But every new run is going higher, not lower, and the direction of that trend has not reversed since spring. For the coming week, here is what I am watching most closely. The expansion of extreme heat into the upper Midwest Tuesday through Thursday. Whether the European ensemble maintains its signal for the ridge to strengthen again over the plains late next week, or whether a trough finally undermines it and provides real relief. The fire weather situation in California and the Great Basin over the next 48 hours, as dry lightning potential is assessed as probable this morning, and the flash flooding risk along the Gulf Coast and central Texas as the eastern margin of the heat dome generates heavy convection with training storm clusters. These are not separate stories sitting in different segments of a weather broadcast. They are chapters of a single connected event that is going to define the rest of this summer. Heat dome number 1 hit the east. Heat dome number 2 is peaking in the west today and moving east as we speak. And the driver behind both, the rapidly strengthening El Niño, is still accelerating. Tomorrow I will be watching Billings closely to see if that all-time temperature record actually falls. I will be checking the fire weather reports out of Northern California and the Great Basin for confirmation of the wildfire ignitions that were projected this morning, and I will have the updated European and GFS ensemble runs for the third week of July, because that is the window where the models start to diverge on how persistent this second dome becomes. If you found this video useful, share it with someone who is in any of the areas we discussed today: the West, the Midwest, the Great Lakes. The decisions people make in the next 48 hours about outdoor plans, travel to national parks, outdoor work, those decisions matter when all-time temperature records are on the line. Like this video if the data here helped you understand what is actually happening, and drop your city in the comments. I genuinely want to know where you're watching from and what the heat feels like on the ground in your area right now. Let me take you back to something that happened during the first heat dome, the one that peaked around the 4th of July, because there is a detail buried in the record-breaking numbers that I think tells you something important about what we are dealing with this summer. On June 30th, the overnight low temperature in La Crosse, Wisconsin, was 81 degrees at its coldest point overnight. That tied the city's all-time warmest low temperature, a record that dates back to 1872. 154 years of records, and that record, for overnight heat, not daytime heat, was tied. In Illinois, Des Moines, Louisville, and Topeka, overnight lows also broke records on that same night, all on the same night. That pattern, overnight lows refusing to drop, is one of the most dangerous signatures of an intense heat dome. Your body can tolerate a hot day if the night gives it time to cool down, When overnight lows stay near 80 degrees, there is no recovery. The thermal stress accumulates. It compounds over consecutive days. That is why heat events with warm nights cause disproportionately more health impact than those where temperatures recover overnight. And that is exactly the pattern the Climate Prediction Center is projecting for the Midwest in the days ahead. Overnight lows dropping only to the mid to upper 70s to 80s, day after day. I want to walk you through the infrastructure dimension of what back-to-back heat events like this do to a country that is not built for it. When the first dome hit New Jersey on July 3rd, 250,000 customers lost power. Not from tornadoes, not from thunderstorm winds directly. From an overwhelmed electrical grid trying to meet the cooling demand of millions of people running air conditioning simultaneously during a prolonged heat emergency. The grid was not hit by a storm. It buckled under demand. New York City saw its Central Park temperature reach 100 degrees for the first time since July 18, 2012. 14 years. And in the days leading up to that, Amtrak had to slow train speeds on the Northeast Corridor because of heat-related track concerns. Rails expand and can buckle under extreme heat. Airlines cancelled and delayed flights due to heat-related limitations on aircraft performance. These are not edge-case scenarios. They are documented infrastructure responses to temperatures we are now seeing repeatedly. Chicago has reached 95 degrees so far this summer. Indianapolis, 93. Omaha, 96. None of those are all-time records. Yet. But they represent the new seasonal ceiling in cities that are about to see their highest temperatures of the year in the coming days. And unlike the West, where low humidity keeps the heat index closer to the actual temperature, the Midwest draws moisture northward from the Gulf. When you add Gulf humidity to 100-degree air, the heat index climbs to 105, 110, 115 degrees. That range, 105 to 115, is what the Climate Prediction Center is specifically projecting for the Midwest midweek. There is something I want to emphasize about the drought dimension of this story, because the agriculture impact is going to be felt for months. The heat dome interior, the zone beneath the ridge core, suppresses precipitation. Cloud formation is inhibited, convection is capped, the sky is clear and relentless, and corn and soybean crops across the central Midwest are entering one of their most water-sensitive growth stages right now. The silking and grain fill stages in corn require consistent soil moisture. When the dome parks over an area for multiple consecutive days with no rainfall and temperatures in the high 90s to over 100 degrees, evapotranspiration rates skyrocket. The soil loses moisture faster than it can be replenished. Crops that already needed rain last week are going into this heat event without a buffer. AccuWeather's drought analysis specifically noted that the second heat dome is expected to cause drought to expand and merge across the central plains, creating what their forecasters described as one continuous zone of stress from the Rockies to the plains. Nebraska, Kansas, Colorado, and Wyoming are already in that corridor. When the dome expands east next week, Iowa, southern Minnesota, and parts of northern Missouri enter the picture. The farm economy across a significant portion of the country's breadbasket is going to be tracking this heat event with serious concern through at least mid-July. And yet, this is the part that does not get told clearly. The drought impact is not uniform. While the dome interior is baking dry, the eastern and southern margins of the system are generating heavy precipitation. The Weather Prediction Center flagged a slight risk of excessive rainfall across Texas and the central Gulf Coast for Monday and Tuesday. Precipitable water values in East Texas exceeding 2¼ inches, Corfidi vectors oriented north to south supporting backbuilding and training convection. What that means in plain language is that storms are expected to repeatedly form over the same areas rather than moving through. That is a flash flooding setup. While Kansas and Nebraska have no rain, Houston and Austin may be dealing with flood watches, two completely opposite weather extremes simultaneously, separated by a few hundred miles. That is the dome's effect on the broader pattern around it. Let me bring in a historical comparison that I think gives this summer real context. The summer of 2012 is the one I keep coming back to. That was the summer the United States experienced its most widespread drought since the 1950s. The drought of 2012 covered more than 60% of the continental United States at its peak. Hundreds of daily temperature records were broken across the country. Corn and soybean crop losses were severe. The USDA declared natural disasters in more than half of all US counties. The heat-related impacts to infrastructure, agriculture, and human health that summer were staggering. Now here is the difference between 2012 and 2026. In 2012, there was no El Niño developing in the Pacific. The drought was driven primarily by internal atmospheric variability, a persistent omega block over the United States. In 2026, the atmospheric omega block we are watching is not internally driven. It is being forced by a rapidly accelerating super El Niño that NOAA's own models are projecting will be competitive with the strongest events in the historical record. A forced pattern change is different from a random one. It is more persistent, it has more energy behind it, and it does not simply resolve because a few cold fronts pass through. The ECMWF runs its El Niño forecast from the ocean surface up. The sea surface temperature anomalies in the Ninyo 3.4 region have now reached 1.2 degrees Celsius above average and are rising. Subsurface temperatures, the heat that has not yet reached the surface, are already above where they need to be to support further intensification through the summer. NOAA satellites tracking the equatorial Pacific show a tongue of anomalously warm water stretching from the coast of South America to the central Pacific. The energy is there. The question is just how far the peak anomaly goes. When Severe Weather Europe overlaid their forecast pressure anomaly map for late summer 2026 against the composite from the 4 previous Super El Niño events, the match was striking. A persistent high-pressure anomaly parked over the central United States, a low-pressure area along the west coast, another across eastern Canada extending into the northeastern United States. This is a Rex block pattern over the Pacific feeding into an Omega block over North America. When this pattern locks in during summer, it does not typically release for weeks at a time. The blocking is self-reinforcing, the ridge keeps rebuilding, and the heat, in whatever region the dome is centered, keeps accumulating. This is why I said at the opening of this video that the heat is not quitting. It is not just lingering, it is being fed continuously by an ocean that is getting warmer by the week. The atmospheric response to a building Super El Niño is not a one-time event. It is a recurring signal that will show up in the pressure patterns again and again through the summer and into the fall. There is one more thread here that I want to pull on before we get to what you should be watching in the coming days, and it involves something that most heat dome coverage does not address at all: the smoke. AccuWeather's meteorologist Brandon Buckingham specifically flagged this week that the heat dome will create a temperature inversion beneath it, a layer of warmer air aloft that traps cooler, denser air below and prevents vertical mixing. This inversion is what makes the dome such an effective heat trap, but it also traps smoke. When wildfires are burning actively in Utah, Colorado, California, and the Pacific Northwest, as they have been throughout June and into early July, and the atmosphere is capped by this inversion, the smoke does not disperse vertically. It spreads horizontally across a vast region. We have already seen this. Wildfire smoke from fires in the Intermountain West and Canada has periodically driven air quality into unhealthy and very unhealthy ranges across cities as far east as Chicago and New York City this summer. Under the current heat dome, with active fire weather in California, flagged by Daniel Swain this morning, the potential for widespread smoke spreading across the west and potentially the central United States through the coming week is real. Buckingham's specific language was that the inversion may trap a considerable amount of wildfire smoke over the interior west, resulting in a substantially broad area of poor visibility and air quality. If you have respiratory conditions, asthma, COPD, any lung sensitivity, you need to be aware of air quality forecasts in your area, not just temperature forecasts. The heat kills directly. But smoke reduces the effectiveness of the body's response to heat. When you breathe in particulate matter at the same time you're heat stressed, your cardiovascular system is dealing with 2 simultaneous challenges. Public health officials in Western states have been increasingly aware of this compound risk in recent fire seasons. This summer, given the scale of what is developing, that compound risk is elevated. Let me give you the bottom line for each region over the next 7 days, not just the headline temperature, the full picture. Rocky Mountain West and Intermountain West, Utah, Nevada, Wyoming, Montana, Colorado, you are at peak heat today. All-time records are being challenged right now. Tonight's overnight lows will be in the low to mid-70s, providing inadequate recovery. Fire weather will remain elevated through the week. Monsoonal moisture arrives midweek, which initially brings dry thunderstorm risk and potential wildfire ignitions, before evolving into a more beneficial precipitation pattern later in the week for southern Utah and Arizona. Expect hazy skies from wildfire smoke. Air quality alerts are possible throughout this region independent of the heat alerts. Northern plains, North and South Dakota, Nebraska, Kansas, Minnesota. You're about to see your hottest temperatures of the year. The heat begins arriving in earnest Monday and peaks Tuesday through Thursday. Minneapolis could see its highest temperature of 2026 this week. Heat indices in the upper 90s to 110 degrees are expected. No significant rainfall beneath the dome core. Drought expands. If you grow corn or soybeans, you already know how critical the next 7 to 10 days are. Midwest, Iowa, Illinois, Wisconsin, Indiana, Michigan, Ohio. Your heat arrives Tuesday and Wednesday. The combination of high temperatures and Gulf humidity in this region produces the most dangerous heat index values. A heat index of 110 in Chicago is a different experience than a heat index of 110 in Phoenix, because Chicago's population is less acclimated to that kind of extreme. Vulnerable populations, elderly, outdoor workers, those without air conditioning, face serious risk in this window. Cooling centers and wellness checks are essential infrastructure this week. The South and Gulf Coast, Texas, Louisiana, Mississippi, Alabama, a different threat entirely. While the heat dome's interior is to your north and west, you're in the zone where heavy training convection is expected Monday and Tuesday. Flash flooding risk in central and eastern Texas. Precipitable water values above 2 inches. Back-building storm clusters. If you're in the Houston to Austin to San Antonio corridor, Monday into Tuesday is a day to watch your local watches and warnings for flooding. Appalachians and the Atlantic seaboard. Your reprieve from the first heat dome was brief. The second wave of heat reaches you by mid to late week. This time, the peak intensity may be slightly less severe than what the Northeast experienced around July 4th. Highs more likely in the upper 90s to near 100 rather than the 101 to 106 range from that event. But there is uncertainty here, and the models have been trending the dome slightly eastward with each new run. I would not relax too much if you were in Washington, Philadelphia, New York or Boston. Keep watching the Tuesday and Wednesday model runs. Pacific Northwest, Oregon and Washington. You're on the cool side of the trough that is helping push the heat dome eastward. That trough also brings a cold front to the west coast, which produces one side effect worth noting: gusty winds behind the frontal passage. The National Weather Service in Salt Lake City noted that widespread 40 to 50 mile-per-hour gusts were expected across Utah in association with this front. Oregon and Washington are forecast to see significant rainfall from the coastal side of the front. But east of the Cascades, in eastern Oregon, eastern Washington and Idaho, the fire weather concern remains elevated. Those areas missed most of the rainfall from prior frontal passages and remain in drought. I want to close with a big picture statement that I think this data demands. We are in the middle of a summer that is being shaped by a Pacific Ocean anomaly that is still growing. The 2 heat dome events we have tracked so far, one covering the eastern 2/3 of the country in late June and early July, and the one peaking in the west today and moving east this week, are not flukes. They are the expected atmospheric expression of a forcing mechanism that NOAA says has a 97% chance of continuing through early spring 2027. The heat is not done, and the driver's getting stronger, not weaker. What that means for the next 10 weeks of summer, for fires, for drought, for crops, for power grids, for the millions of people who work outdoors or lack reliable air conditioning, is something I am going to be tracking every single day. The models are going to keep updating. The El Ninyo intensity forecasts are going to keep coming in. And every time there is a meaningful shift, in either direction, I will break it down for you here. Tomorrow I will have the updated NWS discussions for the Northern Plains as the heat dome pushes east. I will be watching Billings to see whether that all-time record falls today. And I will have the first look model data for the 3rd and 4th weeks of July, because that is the window where the question of how persistent this second dome becomes is going to start having clearer answers. If you want to stay ahead of this pattern, not just catch up to it, hit subscribe now. Like this video if the forecast data helped you plan, and drop your city in the comments. Tell me what the heat feels like in your area right now, because the difference between a forecasted number and the lived experience on the ground is something I genuinely want to understand from every part of this country. I need to add something here about the human health dimension that I think is being undercovered. When we track temperature records, we talk about the numbers: 111 in Billings, 106 in Salt Lake City. But the heat that kills people is not always the heat that makes the headlines. Heat kills through a series of physiological failures that begin long before the temperature reaches its daily maximum. And the population most at risk in each of these regions is not the healthy adult who notices the heat and goes inside. Extreme heat in the United States kills more people on average than any other weather phenomenon, more than tornadoes, more than hurricanes, more than floods. The National Weather Service tracks this every year, and the pattern is consistent. Heat is the silent killer. It does not break windows or knock down power lines or put a dramatic photograph on the front page of a newspaper. But it accumulates deaths steadily across a heat event, disproportionately among the elderly, young children, outdoor workers, those with cardiovascular or respiratory disease, and those without access to air conditioning. When the first heat dome hit the east around the 4th of July, the one that brought Atlantic City to 106 degrees, and New York City to 100 degrees for the first time in 14 years, the initial attributed death toll reported by Wikipedia's real-time tracking of this event was 44 deaths as of July 8th. That number will almost certainly rise as health data from the holiday weekend is fully processed. Heat-related deaths are notoriously undercounted in real time because they often present as cardiac events or respiratory failure without immediate attribution to heat exposure. Some studies suggest that actual heat mortality is 2 to 5 times higher than officially attributed figures in the days immediately following an event. Now here is the critical public health point for what is coming this week. The Midwest and Northern Plains population is, statistically speaking, less heat acclimatized than the South or Southwest. A person who lives in Phoenix is physiologically adapted to tolerate 100-degree heat in a way that someone in Minneapolis is not. When Minneapolis, which has topped out at 92 degrees this summer, faces temperatures in the high 90s to 100 degrees, with heat indices above 105, the physiological impact on its population is more severe than the same temperature would produce in a more heat-acclimatized city. This is the variable that emergency managers in the upper Midwest need to be thinking about right now. Not just opening cooling centers for people who seek them out, but actively reaching high-risk populations who may not recognize that they are in danger. Elderly individuals living alone in older housing stock without central air conditioning are particularly vulnerable. Urban heat island effects in city cores mean that overnight lows in neighborhoods with less green space and more paved surface can be 5 to 7 degrees warmer than the official airport observation that goes into the forecast. The official low of 78 in Minneapolis may mean 95 on certain block faces in dense residential neighborhoods. I want to give you one more piece of data that I think crystallizes the compound nature of this event. Wildfires have burned more than 3.3 million acres across the United States so far this year, significantly above the historical average for this point in the calendar year. The National Interagency Fire Center's preparedness level has already been elevated. Most of that burning has been concentrated in the west, with Colorado and Utah seeing destructive fires in recent weeks. The Iron Fire in Utah burned more than 37,000 acres before containment was achieved. 3 firefighters were killed in a burnover event along the Utah-Colorado border at the peak of the wind event earlier in the season. That is not background noise. That is evidence of just how dangerous the current fuel conditions are. Now add the following on top of that baseline. The second heat dome is arriving at a moment when drought has expanded across the west. Soil moisture is near historic lows. The snowpack that would normally provide some buffer of moisture into early summer has been completely depleted, and dry lightning is specifically forecast as probable over California's mountains today. This is not a situation where the fire risk is merely elevated in a statistical sense. It is a situation where the ingredients for rapid fire growth are stacked. Climate scientist Daniel Swain noted in his Weather West analysis, posted just hours ago, that fires ignited by dry lightning can smolder quietly for 1 to 2 days before becoming active, waiting for conditions to warm up and dry out. That means any ignitions that happen today or tonight may not manifest as visible fires until Tuesday, and by Tuesday, the heat dome is fully entrenched, temperatures in the affected areas are at their peak, and relative humidity is at its lowest. The timing is about as unfavourable as it could be. Let me take you into the space weather dimension briefly, because there is something worth noting here. The sun has been active in recent weeks, with multiple flare events. The KP index, the Planetary Geomagnetic Activity Index, has seen elevated readings during the most recent solar activity periods. This does not directly cause heat waves, but elevated solar activity during a period of already extreme surface heat creates an additional layer of context that space weather trackers are monitoring. NOAA's Space Weather Center provides updates every 3 hours, and during active flare periods, aurora sightings are possible as far south as the northern tier of the United States, which is actually something worth watching on clear nights this week if you are in Montana or the Dakotas, even as temperatures remain elevated. I want to return one more time to the El Niño storyline, because I think the most important number in this entire forecast is not 111 degrees in Billings, it is 63%. That is NOAA's stated probability of a very strong El Niño during the peak window of November 2026 through January 2027. That number has been rising with every successive model run this summer. The direction is one way only, upward. And every time I see a new number come in higher, I think about what that means for the autumn and winter patterns that are going to follow this summer. Previous Super El Niño events have produced dramatic winter precipitation anomalies across the southern United States, elevated storm track activity across the Gulf Coast states, unusual warmth across the northern tier, and significant disruption to the Atlantic hurricane season. We are already seeing that last effect. NOAA predicted a below-normal Atlantic hurricane season for 2026, citing El Niño-induced wind shear as the mechanism, and so far the Atlantic has been relatively quiet. But the Eastern Pacific is a different story entirely. Warm sea surface temperatures in the Eastern Pacific are supporting elevated tropical storm activity off the coast of Mexico and Central America. The Gulf and the Caribbean are being watched closely for any tropical development that might squeeze through the narrow window of low wind shear. The full implications of a Super El Niño for autumn and winter patterns are something I plan to cover in depth as the season develops and the peak intensity becomes clearer. But for now, for this week, the immediate relevance is this. The ocean anomaly that is driving this summer's recurring heat dome pattern is not at its peak. It is still building. The atmospheric response we are seeing in July is happening at a time when the forcing from the Pacific is still in the early to middle stages of its intensification. What the atmosphere looks like in September and October, when that forcing peaks, that is a question worth keeping in mind as you watch this summer unfold. The heat is not quitting because it is being continuously fed. That is the honest assessment of where we are today, July 12th, 2026, as Billings, Montana, attempts to break its all-time temperature record and Salt Lake City approaches the highest mark in 152 years of records. The mechanism producing these events is getting stronger by the week. Stay with me on this story. I will have updates as the dome moves east, as the fire weather situation develops overnight, and as the latest model runs come in through the week. Tomorrow's breakdown will include the updated European ensemble mean for the third week of July, and I think that data is going to be important. Let me take a closer look at the mechanics of how this second heat dome formed, because understanding how it built is important for understanding why it is so intense. And it goes back to a sequence of events in the Pacific that most people missed, because they were focused on the eastern heat dome at the time. While the first heat dome was baking the East Coast around the 4th of July, Atlantic City at 106, New York City at 100 degrees, Washington at 103, the GFS and European models were already beginning to show a new ridge building in the west. This is not unusual. Heat domes do not disappear when they weaken over one region. The energy often redistributes. The upper-level ridge that powered the eastern event left behind a primed, warm air mass across the central plains that the new western ridge could tap into. The mechanics that the Weather Prediction Center described in their Sunday morning forecast discussion are specific. An intensifying upper-level high centered over the western United States is working in concert with an upper-level trough digging toward the Pacific Northwest. Think about those two features together. The trough to the northwest acts as a pump. It pulls warm air northward on the east side of the trough, feeding the ridge over the west. Meanwhile, the ridge itself acts as a blocking mechanism, preventing any incoming Pacific troughs from undermining it from the west. The result is an almost self-sustaining system that can maintain extreme heat for multiple days without significant disruption. This is why the NWS in Salt Lake City described this as the most significant heat wave of the season, not just because of the temperatures involved, but because of the confidence with which forecasters can project those temperatures several days in advance. The ridge is anchored. It is not going to suddenly shift. The models are in strong agreement. When you have that kind of forecast confidence at this temperature extreme, that is a meaningful signal that this is not an ordinary event. Let me walk you through the specific records that are on the line right now and in the coming days, because I think the magnitude deserves to be spelled out city by city. Billings, Montana, all-time record, 108 degrees, set July 14th, 2022. Today's forecast high, 111 degrees, according to AccuWeather and the Weather Channel. If that verifies, it breaks the all-time record by 3 degrees. In 92 years of records, Billings has never seen a high temperature in the 110s. Today, it may. Salt Lake City, Utah. All-time record, 107 degrees, set 5 times, most recently in 2022. Today's NWS forecast, 106 to 107 degrees. The NWS Salt Lake City office itself called this the most significant heat wave of the season. The city may tie its all-time record today. Grand Junction, Colorado. All-time record, 107 degrees. Weekend forecast, 104 on Saturday, 106 on Sunday, within 1 degree of the all-time record. Casper, Wyoming. All-time record, 104 degrees. This weekend's forecast pushes into that range, potentially tying the all-time mark. Now here is a broader stat that I find remarkable. AccuWeather reported that almost 24 locations across eastern Montana and Wyoming are in a position to challenge their all-time high temperature records this weekend. 24 cities, simultaneously, in a single weekend. That is not routine regional heat. That is a historically exceptional event compressed into a small geographic and temporal window. And this is happening, I want to emphasize this again, just 1 week after the eastern United States experienced its own historically exceptional heat event. The first dome set all-time records at Atlantic City, New Jersey. It brought New York City to 100 degrees for the first time in 14 years. It broke daily records across the entire northeast corridor from Boston to Washington. And now, 7 days later, the West is in the same position. The breadth of the record-challenging potential across both events, taken together, is something I genuinely do not have a strong historical analogue for in terms of back-to-back regional extremes within a single summer month. If you have a different take on that, I want to hear it. Drop your thoughts in the comments. Let me also give you some context on what the WPC's excessive rainfall discussion means for Texas and the Gulf Coast this week, because I glossed over it earlier and it deserves more attention. Precipitable water values above 2 inches are exceptional for this region in early to mid-July. That is an enormous column of atmospheric moisture available for rainfall. When the steering flow is weak and the Corfidi vectors, which indicate the direction that storm complexes will propagate, are oriented north to south opposite the low-level wind flow, you get training. Storms form over the same location repeatedly. One storm moves through, and the next one follows right behind it. The result is not the kind of short-duration heavy rain that drains away quickly. It is a prolonged soaking of the same areas over multiple hours. Houston has experienced multiple significant flooding events in recent years. The city's flat topography and extensive impervious surface coverage make it particularly vulnerable to this kind of training convection scenario. Dallas, which sits further inland, has a different drainage profile but is also in the risk zone. If you are in central or eastern Texas, Monday and Tuesday are days to have your local NWS alerts set on your phone. The difference between a slight risk of excessive rainfall and a flash flood watch can close within a single model update. There is a broader point here about how heat domes and flooding interact that I think is underappreciated. The dome suppresses precipitation in its core, which is the Great Plains and Upper Midwest over the coming days. But the margins of the dome are where atmospheric instability is highest. The boundary between the hot, dry dome air mass and the cooler, moister air outside the dome acts like a battle line. Along that boundary, storms can be intense and concentrated. The central Texas flooding setup this week is precisely that dynamic. The dome margin, meeting Gulf moisture with a weak steering flow that allows storms to stall. Meanwhile, the other boundary, the western edge, where Pacific moisture is trying to intrude, is producing the dry lightning scenario in California. So you have the dome core baking the plains and upper Midwest dry. You have the southern boundary generating flooding rain in Texas. You have the western boundary generating dry lightning and wildfire risk in California. One system, 3 simultaneous hazards, different regions, different threats, all connected to the same atmospheric feature. Now let me bring in one more piece of data that I think is going to be relevant for the following week, the North American monsoon. This is the seasonal shift in wind patterns that typically brings welcome rainfall to Arizona, New Mexico, Utah, and Colorado starting in mid to late July. Under normal circumstances, the monsoon is a reliable pattern modifier that reduces fire danger, replenishes soil moisture, and provides relief from the summer heat across the desert southwest. But AccuWeather's long-range team has flagged something important. In the early stages of the monsoon, particularly in a summer where the atmosphere is being reorganized by an accelerating El Niño, the initial convective activity may produce dry thunderstorms, lightning without reaching rain, before the monsoon fully establishes and brings significant precipitation. This means there is a transition period, potentially spanning several days to a week, where the monsoon's arrival actually increases rather than decreases the fire risk. Lightning strikes occur, rain does not reach the ground, and the window for a lightning-ignited fire starting in already parched vegetation at maximum heat stress is at its widest. Buckingham's specific projection was that the dry lightning and wildfire danger during this transition period will tend to push farther to the north, into the Great Basin, the Northern Rockies, as the monsoon slowly expands its reach northward. This suggests that the fire weather concerns are not going to resolve quickly, even as the monsoon begins to influence the pattern. The risk migrates geographically, rather than simply disappearing. For Utah specifically, the NWS Salt Lake City forecast discussion notes that monsoonal moisture is expected to spread into the region by the middle of next week, bringing an elevated threat for flash flooding across southern Utah. This is the abrupt transition from fire weather to flash flooding that anyone who has lived in the desert southwest knows well. The soil is so dry and hard-packed after months of drought and extreme heat that it cannot absorb rainfall at high rates. Even an inch of rain over a short period can sheet off slick rock and hard-panned soil, funnel into canyon systems, and produce dangerous flash floods with almost no warning. The terrain of southern Utah, slot canyons, narrow washes, mesa edges, concentrates that water flow significantly. So here is the week-by-week summary of what every major region of the country is looking at. Today, Sunday, July 12th, peak heat across the Intermountain West and Northern Rockies. All-time records challenged in Billings, Salt Lake City, Grand Junction, and nearly 24 other locations. Extreme heat warnings and watches active from California to the Dakotas. Dry lightning potential over California mountains today and tonight. Fire weather elevated across the interior west. Monday, July 13th. Heat begins expanding into the Central Plains. Denver approaches its hottest temperatures of the year. Flash flooding risk developing across central and eastern Texas as excessive rainfall setup activates. Continued extreme heat warnings in Utah, Nevada, Montana. Tuesday, July 14th. This is the critical day for the upper Midwest transition. Minneapolis, Des Moines, Omaha, and Kansas City begin to see temperatures approach the upper 90s to potentially over 100 degrees. Heat indices climbing into the 105 to 110 range as Gulf humidity mixes in. Crop stress across the Corn Belt intensifying. Drought expanding eastward beneath the dome core. Wednesday, July 15th. Maximum heat in the Midwest. Chicago may see highs in the low to mid-90s, with heat indices near or above 100. Heat spreading toward the Ohio Valley. Indianapolis and Columbus enter the extreme heat zone. Power grid demand peaks across a wide swath of the central United States. Thursday, July 16th. The dome begins its eastward push toward the Appalachians and Atlantic seaboard. Washington, Philadelphia, and New York are watching this day. The models show some uncertainty about peak temperatures on the East Coast. Whether this reaches the 100 to 105 range seen during the 4th of July event, or stays more in the upper 90s. Either way, this is not going to be a comfortable week in the mid-Atlantic. Friday, July 17th and into the weekend. Cold front begins to push southward across the northeastern United States, eventually providing relief to the East Coast. But the Central Plains, Kansas, Nebraska, Missouri, Iowa, may see the ridge strengthen again rather than collapse. AccuWeather's long-range team specifically noted the dome will strengthen again over the plains rather than weaken outright. This suggests the relief will be regional, not national. And for the central United States, the pattern of 95 to 105 degree temperatures may persist well into the third week of July. The wildfire situation in the west will be evolving rapidly through this period. Fire weather advisories, warnings, and watches will be updated daily as the monsoon transition approaches and dry lightning potential shifts geographically. I will be tracking the fire reports out of California, Utah, and the Great Basin specifically because any significant new starts this week will be operating in maximum risk conditions. The El Niño intensity data will also keep updating. The World Meteorological Organization stated that the most rapid strengthening of this event is expected during July through September. We are at the beginning of that window. The forecasts have been consistently revising upward, and NOAA's GFDL model, in its 30-run ensemble for July, showed every single member projecting a peak strength competitive with the strongest events on record. Not most members, all 30. I've said this once, and I will say it again one more time here, because I think it is the single most important framing for this entire summer. The heat is not quitting because the driver behind it is still building, the Pacific is still warming, the atmospheric response is still intensifying. This summer is not past its worst week. The pattern is locked, the forcing is accelerating, and the next several weeks are going to demand careful, daily attention to the forecast data. Stay with this channel through this heat event and through the rest of the summer. The data is going to keep coming, and I will keep breaking it down for you every time there is something meaningful to report.